Hello everybody, this is another chapter of the video series, What Explains Watson AIOps, and we have considered to rename the whole series, so we are shortening it in the naming, so we're saying AIOps Explained in the future, and today we want to talk about how we are addressing incident resolution, and we are using the Cloud Pak for Watson AIOps version 3.2. Or you could also use Netcool Operations Insight version 1.6.3.2, which are the most recent versions. We're going to bring out the newest version of the Cloud Pak for Watson AIOps version 3.3 very soon, but GA is, as of last December, version 3.2, and that's what we're going to use today. So today I am here. My name is Fred Klein. I'm located in Berlin, and we do have wonderful sunshine outside. And with that, I'd like to hand over to Zane to say hello to you.
Hi, I'm Zane. I work in the Netcool Development Lab in London, and I'm here today with Fred to show you the integration that we've done today with the incident resolution system.
What kind of problem are we going to address? First of all, what we want to achieve in general in here is we want to resolve problems as fast as possible, because a problem, an outage or a lag in your infrastructure means something important is not working the way you like it, and therefore, first of all, you need to know it. And after you know you have a problem, you need to know what is the problem, and then you need to do something about it. That's what you want to do, and that in the shortest possible time. And of course, all that is hidden in a vast number of events that are pouring into the system. So therefore, you need to pick the ones which are important to you. This is what we call actionable events. The overall procedure is called noise reduction. You want to separate irrelevant information from relevant information. You want to add extra information in here, and you want to just have actions done by your operations team just on the least possible number of events, and only with the fewest number of persons to be involved in here, to be as fast as possible, and of course to be as simple as possible, because that produces the least cost in the event resolution environment. And because everybody is not in a green field, you also need to consider what kind of systems can take a part in the overall architecture in here. So each IT service management infrastructure is something that is very diverse. So you do have many, many systems to consider, as well as many, many vendors to consider. They can be installed in your local data center, as well as they can be cloud-based, and all that needs to be integrated to run smoothly and efficient as possible. So how do we approach that? Well, first of all, we do talk to the systems which are producing events, and we collect these events. So you need to have collectors in your environment that put status events, problem events, outages, information about lags, other informations to a central place. That's what we call the event management system. So therefore, collection of such data is very, very important, and it's the first stage of the overall process. And then, of course, you need to select those events which are relevant to you, where you need to do something, the actionable events. So you want to remove all the stuff that is irrelevant for you. Maybe you want to delete old stuff that is no longer relevant in the system, but still there. You want to do correlations, for example, if you do have matching events, which tell you that something has been resolved, but the causing event as well as resolution event is still in the system. That is something you want to correlate, as well as you want to age out of the system. And then, of course, you do not want to have single events. You want to have them nicely grouped by various attributes. For example, if there's a common theme, for example, an outage where you need to do something, or a location that has a problem, these kind of groupings are very, very significant for you and help you in the resolution of the later cause. And of course, you want to have extra information within the event. So everything that provides extra information and is beneficial to the resolution of the problem. For example, where's the location? Is there somebody who needs to know I need to involve into, or is there an SLA which I need to fulfill for something like all critical events need to be resolved within 1 or 2 hours. We need to inform a specific SLA administrator. All these kind of things that are relevant to you, that need to be in the process, is something we call event enrichment, and it is additional data that we can put into the overall system quite nicely using our capabilities. And then, of course, if we have grouped all these events, if there is something that can help us with the evaluation of those events. So you have 20 events, they're all grouped into relevant for one single problem, but who's the bad guy? That's something we name causation. And that's also supported by the software. And Zane is going to show you how that is going to work and what's the effect of that. And of course, we want to resolve things. We want to automate the resolution process as much as possible. And that's something we're going to showcase here with the runbook automation capability of the Cloud Pak for Watson AIOps. And today we have a very specific setup, which is a subset of possible architectures. And one of the possible architectures we do have is the hybrid architecture. What you can see here is the most common installation that is out there in our customer base. This is a hybrid one-tier or multi-tier architecture. The one-tier architecture, this is because we just have a single pair of object servers in here. If we do have multiple pairs, for example, collection object servers or visualization object servers, this is then called a multi-tier architecture. And this is enhanced with the additions of Netcool operations inside, as well as the Cloud Pak for Watson AIOps. This is all here, all the new stuff that is coming here on the OpenShift cluster. This is the Cloud Native Event Analytics engine, as well as runbook automation, Cloud Native integrations, topology, as well as the AI manager itself, plus third-party integrations, for example, a ticketing system like ServiceNow or Slack integration here as the ChatOps capability for the AI manager. All that is a very, very typical scenario and a hybrid architecture. Also, it can be placed all on OpenShift. For example, this is a picture which would look like that. So we have all the major components here on a single OpenShift cluster, and we would have third-party integrations outside that OpenShift piece in here. So this is how these kind of architectures more or less look like. Always you have in detail in your specific environments, special requirements, other integrations as well, which do variations of these kind of architectures, but these two architectures are the most common in our environment. And with that, I'd like to hand over in today's architecture. Zane, over to you.
Thanks, Fred. Yes, so today the scenario we're looking at is where we are integrating with ServiceNow. What we're going to look at today in the demo is a scenario where we have a ServiceNow observer to bring the topology data into the event manager. Then we are going to inject some events which match with the ServiceNow topology. We will see how to create a topology template, which causes the correlation of those events together based on the topology. We will see how those events are grouped together using topology-based correlation. Then we will see an integration using Impact into ServiceNow. So that's going to do two things. It's going to do an in-maintenance check, first of all, to check to see whether or not each event or the node behind each event is in maintenance. If it's in maintenance, we don't need to worry about the event. We can just downgrade the severity and suppress it. And then the second part of the integration, we are going to create a trouble ticket, and we're going to see how that integration is done. Then we're going to see how the runbook that we have is associated with the scenario, and then run the runbook. And then finally, we're going to close the ticket and then see the events get updated in the event manager.
And with that, we're going into the demo, aren't we?
Yeah. So I will share my screen.
Yes, please.
Okay, so let's take a look at our setup first of all. So first of all, in the topology management, I have a selection of different observers, and I've created a ServiceNow job. So this ServiceNow job is tapping into ServiceNow, and it's pulling back the topology data from ServiceNow. Yeah. The next thing I've done is I have gone in and defined a template. So for my template, I have got a bunch of different kinds of resources, which I'm getting from ServiceNow. And for this example, I've defined a template called Linux server. So a dynamic template is really useful because it allows you to provide an example of a collection of resources, and then it will go off and find all of the examples contained in your system automatically. The nice thing is that if more Linux servers are deployed into my environment, the template will automatically update and include those ones as well. Key to doing this particular scenario is the fact that I've got this button toggled, which tells the system to correlate events that are received within each grouping that is found. Right, so now that we've set up that, the other thing we've got set up in the background is a sample runbook. So this runbook is created, and if I edit it, you will see it's made up of a single step, which is an automated step. And the name of this automated step is called Scale Up CPU. So let's take a quick look at this particular automation and see how it looks. So this is the Scale Up CPU automation here. And it's simply making a HTTP call to a REST API, passing in some credentials, and performing a task on that API. And then, so that's our automation, which is in that runbook. To associate this runbook with our events, I've created what's called a trigger. And the trigger simply has a filter, more or less, where the manager equals VMware and the alert group equals hypervisor. So in the case that I receive an event that matches this criteria, I'm going to associate this runbook with those events. And I'm going to pass the host name from the event from the node field. So now that I've got my system set up, let's run through the scenario. Just before we do, we'll take a look at the integration into ServiceNow. Using the automations here, I've got Netcool Impact running. And in Netcool Impact, what I've done is I've created two different policies that are being run by two different services. The first one is checking every event that comes through the system to see whether or not it is in maintenance or not. If it's in maintenance, obviously we don't want to create a ticket. We probably don't even want to bother our operators with it. We just want to suppress it. So that's what this policy does. So the first half of the policy is simply defining all the connection parameters to ServiceNow's REST API. It then makes the call to ServiceNow's REST API. And then if it's successful, it parses the JSON payload coming back, and it checks the is on maintenance property. If it's yes, you can see it sets the suppress escalate field to 4 and the severity to 1 and updates the event. So very simple policy. Behind that policy, we have a service. And this service is a simple event reader. Runs every 3 seconds, which is the default for Impact. And all it's doing is it's picking up events that match my filter and running that policy. You can see that I have get updated events unchecked, which means it's only going to process events once and once only. Then once the events are in, I have a second policy defined. This one is a little bit longer. I don't need to go through it all, but I'll go through it at a high level. So this one is working off the basis of a state diagram that I've devised. So this state diagram basically outlines the different states that a ticket can have in ServiceNow. It's nice for me to understand this workflow when I do create an incident in ServiceNow, the various states that my ticket will transition through. And then that's nice because then I can reflect that back onto the events back in the event manager where the ticket's raised. So I've created the state diagram, and I've mapped a simple integer value onto each of the states. One where I initially make the request to ServiceNow to open the ticket, which is opening, and then it's got a number of different states that map to the ServiceNow states, ticket states basically. New, in progress, on hold, resolved, closed, and cancelled. What I've done in the event manager, meanwhile, is I have created a new field to hold my ServiceNow state. And it's an integer field. And I've created some conversions just to make it easier to deal with the ServiceNow field as an integer field. But when I look at it in the UI, I want to be able to see human readable text. So I've created a simple conversion in the object server, which will, instead of showing me 0, 1, 2, 3, 4, 5, and so on, it will actually show me the actual string instead. And this makes it easier when I'm working in my policy to simply refer to integer values instead of having to deal with strings. What this policy does is it's backed by a service, which is another event reader service, right? But this time it's getting updated events, which means it's periodically reprocessing events that are in ServiceNow state 1, 2, 3, 4, or 5, right? So basically events that have a ticket requested or are in one of the non-closed states. So 1, 2, 3, 4, 5. While this policy is running, it will reprocess these events and try to progress them through to a closed state by running them through the policy. So the policy is going to do one of two things. First of all, if it picks up the event and it's a number 1, which remember is a request to open a new ticket, it's going to build the payload, which ServiceNow requires, the JSON payload to open a new ticket, make the request to ServiceNow, and then go off and open the ticket. If it's successful in opening a ticket, it's going to put the ticket number in the relevant field and set the state and do a few other things. A couple of other things that we're doing here is we're looking at the SLA status of the incident once we open it in ServiceNow, so we can actually keep updated in the event manager as to how much time we've got left to resolve the incident. So that's the new incident request possibility, right? So if the ServiceNow value is 1. Else, if the ticket number is not null, it's going to just basically try to update the state of the event based on the incident in ServiceNow. So it's got a few if-else constructs in there that just update the event on the event manager side based on the different settings.
It looks complicated, but it isn't. So it's encapsulated if there are else statements.
Yeah, it's just a little bit spread out to make it easier to read. But basically, these last few if-else-if statements are just saying if it's a 5, if it's resolved, I'm going to set the severity to 1. If it's a 6, if it's closed, I'm going to clear the events that are under it. And if it's a 7, I'm going to do that basically corresponds to a cancelled status, which basically resets the events and makes them eligible for ticketing again. So now that we've had a look at the actual policies involved, let's actually run them through and watch them in action. But what I'm going to do is I'm going to open up a impact policy logger. And so we can actually see the logged output coming from the policies and see what it's doing in the background. Let me just expand this. I'm going to filter on ServiceNow. Apply that filter and just clear it. So we're ready to go. Right, let's go back to the event manager. So I'm going to inject some events. And remember, the first thing it does is it will check each event to see if it's in maintenance or not, right? So let's start by injecting our synthetic events. For convenience, I've created a simple tool that will just insert these events. I'm going to run that now. You can see here it's actually inserted a bunch of events. There's one from an Oracle server and another one here from a bond trading application, one from electronic messaging, a message from client services saying that it's scaled down the CPU allocation on a particular server. And that is the set of events. So because
these are typical events which are received via probes or any other means.
That's right, yeah. It's a good point, Fred. And these events could be coming from any particular source. Indeed, if we scroll across to the right, you can see they've come from different application response or a hypervisor or table status or noise status, different sources of events. Because I created that template, these events should, first of all, be grouped. So we can see we've got a new group of events that's happened. And if I click on the correlation information on the right-hand side, you can see they've been grouped by topology-based correlation. You can see the little bullets here in the topology-based correlation column. If I click on one of them, it gives me a little preview of the piece of topology that has caused these events to be correlated together. You can see this event's come from bond trading, this event's come from Linux 100, and this event's come from client services, right? So we understand now why these events have been correlated together, because they're in a predefined topology. Second thing, looking at the timestamps of these events, I can see that I've got an information event here, and it's low severity. It's not an alert, but what it's done is it's just an information event to let me know that somebody or something has scaled down the CPU allocation on this virtual machine Linux 100, right? Now, shortly after that, I've noticed my monitoring service complaining to me that the utilization on that particular server is now over 90%. Also, I noticed that I'm getting a couple of application events from the electronic messaging service and the bond trading service to tell me that they are now experiencing performance issues, messages not received in the past 2 minutes, and the transactions taking longer than expected. So the nice thing is these particular side effects have been linked to the actual box Linux 100 because of the topological association. The topology is telling me that these things are connected and there's dependencies there. And that's really useful, first of all, to see that these events are actually related to each other. The second thing that's going on is, as a first-line operator, I'm looking at this and I'm thinking, right, chronologically, someone scaled down the CPU allocation on the box. Next minute, the CPU utilization has gone through the roof. And then the next minute, the applications that are dependent on that box are failing. So it's now, because of this convenient correlation that's happened, it's now quite clear to me what's happened and why it's happened. If I look along to the left, I get a little bit of a confirmation as to what the probable cause of this particular problem is, as highlighted by the probable cause column. And I can see that, indeed, the fact that someone scaled down the topology is probably the cause of what's happened here. So what to do about it? Well, the first thing I'm going to do is create a ticket. Before we do that, we can see at the bottom, okay, so now I'm going to insert some test events, and let's watch the log file, see the messages. You can see it's checking the various servers to see if they're in maintenance, and you can see that the last one is in maintenance. It has suppressed the event, as you can see here.
Suppression means a change in severity as well as a suppress escalated flag set.
Yes, in this case, what we've specified in the policy is to set the suppress escalate flag to suppressed and reduce the severity to 1, regardless of what it was before. So if we have a look at the events again, you can see that this event is suppressed. And meanwhile, the other events have been grouped and are continuing to be processed in the normal way.
And you could maintain your filters on the visualization to show only normal events.
Correct, yeah. So you could hide all of the suppressed events. I mean, you might also just simply clear it straight away or just delete it straight away. But for the purposes of this exercise, we're just marking it as suppressed so we can see what's happening.
Well, and even events within a maintenance window may run out of the maintenance window and still be there. So you need to revoke them. So keeping those in the background is a nice idea.
Yeah, and the nice thing about this system is because in this particular use case, ServiceNow is our source of truth for information. We're actually going, as the events come in, we're going to the source of truth to say, is this node in maintenance now? And that way we get the very latest in maintenance information. Right, so the first thing I want to do as an operator is I'm going to create a ticket so that I can track the status of the service request through to the closure and the resolution of the problem involved. So here I'm going to manually create a ticket simply by clicking Create ServiceNow Ticket. So what this is doing in the background is it's actually talking to ServiceNow, as you can see from the impact log. And you can see it's made a request to ServiceNow to create a new ticket. And it's come back with the ticket number with a status of new. So ticket number 10,040.
And we can see opening, and now it's new, and with the ticket number.
That's right, in the UI. So if I go back to my event viewer, you can see I've got a ticket number here. And this has nicely propagated to all the children, just to show you that these events are all in relation to ticket number 40, and you can see its state there.
Do we have any other effect with the ticket number, for example, exclusion from deletion and these kind of things, because they may be of interest, so you don't want to delete them?
You could certainly wire the system that way, that's for sure. I mean, it already has a system in place where parent events won't automatically be deleted until all the children are gone first. So we're going to see how that looks shortly. One thing also to note here is that the SLA time and the SLA stage is also being tracked on the right-hand side. If you recall, when we were looking at the policy, that was one of the pieces of information it was pulling back, and we can actually see that information coming back in the payload. See? You can see business time left, 1 hour, 59 minutes. So we're just taking this information and just putting it in the event because it's quite handy to see. While I've been talking, you can see this has now changed to 1 minute 58 because the clock is ticking. And it's quite nice because as an operator, I can see how much time I've got left. Right, so this particular problem is underway. While I'm a first line operator, I may not necessarily be a hypervisor expert, and I don't necessarily know how to resolve this problem. I can see that someone scaled down this CPU allocation, but I don't really know how to fix it. But fortunately, the runbook, which we looked at earlier, has been automatically associated with this particular problem. Before I do that, I'm just going to go into ServiceNow, and I'm going to change the ticket state from new to in progress. So I'm going to run another tool to launch straight into ServiceNow.
And this is actually how a normal operator would behave as well.
Yep. So as you can see, it's one of the things that came back from Impact when I created the ticket was the URL to the ticket, as you can see here in the payload. So all I've done is I've simply just stored that in the event, and I've created a simple right-click tool which launches to that URL. So now I'm launching straight into the ticket. I can manage the ticket from here. I can jump back to the events from here. And I can say, right, I'm going to work on this problem now. So I'm going to change the ticket state to in progress. And we shall see that status come back. There we go. So now this has updated the event. It should now say in progress. Right.
Ta-da!
So now we're going to start working on the problem, and maybe I might run this runbook because it's there. So I can read here, scale up CPU. This automation connects to the hypervisor and upgrades the CPU allocation for the specified host. So that sounds good. An SME has written this runbook, and they have decided that this works. So this is going to run this particular automation. I don't need to be an expert. I don't need to copy and paste anything. I just need to follow the instructions and click the run button. So it's done its call to the API. It's upgraded the CPU for the particular host, and I can see that it's been successful. I can mark it as complete. I can give some feedback to the runbook automation author to let them know that it worked fine. The runbook worked. So now I'm looking at this. I've run the runbook. I can monitor this for a while. If this was a real system being monitored, if this was really real events coming in, I would see that the monitoring system monitoring these particular services and servers would actually mark these events as resolved. Alternatively, I might go over to the ticket and I might say, hey, I've fixed this problem. I'm going to enter some resolution information here. I've solved it with a workaround. It is now fixed. And I might update the ticket. And I might say, this ticket is now going to be marked as resolved. So click on the resolve button. So now that that's done, if I go back to the event viewer, I will see that update come through, just like the others. There we go. And I'll go back to the event viewer, and I will see that incident become resolved. As you can see there, it's now changed from being in progress to resolved. And in the event viewer, it's now showing as resolved. So this is great. This ticket can then be checked by a supervisor. They might say, okay, maybe let me do some checks, make sure that everything has come back up. Everything's running as it should be. I'm going to go ahead and close this ticket now because it all looks good. So let's close that ticket. And we're going to observe Impact check that ticket again within a few seconds. Notice that the ticket's been closed and clear the underlying events. So you can see a few things have changed now. First of all, the underlying child events have all been cleared. the ticket status is now closed. And you can see the SLA time left and the SLA stage have updated. So I can see that it's completed and I've done it within time. So there's still some time left on the SLA clock. So this is all good. It means that I've met my SLA, and you can see these events have now moved to the bottom because they are of low severity.
And just remember that the bad guy in these events, it's just a low severity event. So there are many operators who are looking just on critical events or major events. Yeah. And you may miss the important piece by doing so.
That's a very good point, Fred. And, sometimes we use an approach to filter out what we think are the low importance events, when in fact they might be the information event that preceded everything falling down. So being able to see those events is very, very useful. But what we need is effective event correlation in order to be able to have that information presented to us in a meaningful way. In this case, having the information event was critical to us actually seeing what was going on and actually indicating the probable cause. But it was the effective event grouping that allowed us to see the correct context.
And that, of course, at scale. So if we're thinking of something like 100 million events pouring into our system each and every day, then you really need this kind of AI support to really sort things out.
Right. Thanks, Fred. That's all I have for today.
I like it. This is really a great showcase. This is not a 100% real life use case, but it's very close to it. So we are not having real events. We are not resolving real events, but that would be the missing piece. So for example, if you do have a system like Instana or Nagios or any other monitoring system attached to it, which are claiming there's a problem in an environment, and you receive a few events out of these environments. They are correlated in here on the Cloud Pak for Watson AIOps level. They are reproduced in ServiceNow with a ticket. We do have an escalation procedure in here, event enrichment and so on attached to it. And then when we resolve the issue by enhancing a few resources that are associated to the servers, then the whole thing settles down and we would receive the good events again. And the overall system would correlate these resolution events and the whole thing would automatically resolve in here. So that is the missing piece. But I guess, Zane, you showed it how it works in principle, and that demonstrates the whole use case quite nicely. And you also showed that the overall thing is more or less out of the box. So we do have all this grouping and correlation in place out of the box. So what is not out of the box is the ServiceNow integration. That is something you have configured. You have configured a runbook that is associated to that. So these are the ones to be set up pieces, and then the overall process would work. So this is typically something we would achieve using a expert labs approach. So we talk about what kind of things do you want to integrate into your environment, and we would do that using expert labs or a business partner. Really well-educated customers would do it themselves with their administrators. So we do have these kind of customers as well, but that's it. So this scenario is really more or less out of the box there and working. I really appreciate your time putting it together and showing it to us today.
Yeah.
And
just one last comment on the runbook. As an author, I can see that my runbook works really, really well, right? So one thing that you can look to do, and this is what our customers like to try and work towards, is eventually, once you've tried and tested your runbook and it works, successfully for a month or so, you can actually switch it to be fully automatic. And what that means is no longer does the operator need to run the runbook manually and click through the steps. They might instead simply, the events would flow in, the runbook would run, and it would automatically correct the problem. And that's something that you can do once you've had the runbook running against real events in production for a while. And maybe we can avoid any sort of service outages, and maybe we don't even need to open a ticket. So this is where we sort of try to evolve towards, is that having that self-healing environment. And that's something that is achievable with the Watson AIOps Event Manager.
So thank you very much, Zane, for showing us this integration and how Cloud Pak for Watson AIOps really works and in this kind of use case and environment. We are going to produce over the year more of these kind of videos. So I'm looking forward to have two more, which are specifically more about runbook automation. And we are considering currently also something more on the AI side, as well as we are looking forward to having some type of enablement, which is coming with the new release, which is going to be there in the near future. So watch the space. Thank you, Zane, and see you next time.
Thanks, Fred. Bye.